So I started by isolating the variables y by themselves on both equations, and I determined the slope and the y-intercept for each one of those problems. So the first equation has a slope of 1 and a y-intercept of 0, -5. So I'm starting at -5, and the slope is 1. So I'm going to go one step up, one step right, and so on and so forth. And so my line is going to look pretty much just like that. So that's the equation that is called x minus y equal to 5. Perfect. And the second equation, I have a slope of -2 and a y-intercept of 0, 1. So the 0, 1 is the y-intercept, and the slope is -2. So that means I'm going to go down 2 steps, over 1 step, down 2 steps, over 1 step. So my line looks pretty much something like this. And let me make sure to slide it over. There we go. Perfect. So at this point, I'm going to decide what the intersection point is. So this is the line that we called 2x plus y equal to 1. It seems to me like the intersection point is happening over here somewhere around the 2 on the x-axis and -3 on the y-axis. So I think my answer should be 2, -3. And again, I'm going to say the word consistent and independent. And that's because there's only one intersection point on the graph. Independent. Okay. So again, with the calculator, here's what it looks like. First, I type in the equations x minus 5 into y1, and then the second equation, -2x plus 1, into the second equation, y2. And I'm going to click zoom 6 to make it all nice and pretty. And I want the intersection point. So I'm going to go second, and then click on trace to get into the calculate menu. Pick option number 5, which says intersect. Now, select the first curve, then select the second curve, then guess. And again, you see the numbers are 2 and -3, exactly the ones we predicted. So that means we're finished.